Hi, I'm Jason Tollefson, XLP Marketing Manager for Microchip Technology. This is the second installment in our video series highlighting microcontrollers featuring nanoWatt XLP, the world's lowest sleep current technology for microcontrollers. So many people enjoyed our first video highlighting the extreme low currents of the PIC24F 16Ka device family that we decided to show you more PICs with amazingly low sleep currents. We'll once again be using our XLP current measurement board to show you the currents consumed by the PIC16LF72X family and the new enhanced mid-range PIC16LF193X family of microcontrollers. This simple measurement system allows us to easily switch between commonly used low power modes. This is great for showing our low power consumption in real time, supporting the information found in the datasheet. It also allows us to compare our XLP microcontrollers to leading competitors. Here you see the XLP current measurement system. If you haven't seen our first video, it consists of Microchip's Explorer 16 development platform and this current measurement daughter board. The measurement board provides communication to the device under test, as well as high-resolution current measurement. The current measurement is capable of single-digit nanoamp current measurements. The Explorer 16 controls which mode is being entered by using these 4 buttons. The current is displayed on the LCD display. All measurements seen here today will be with the device powered to 1.8 volts and at room temperature. I'd like to begin the demonstration by showing you Microchip's PIC16LF722 device featuring nanoWatt XLP technology. Most battery-powered applications spend 90 to 99% of their time in sleep, so we'll begin in sleep mode. We'll then show the essential low power modes, sleep with watchdog and sleep with real-time clock. By pressing this button, we exit run mode and enter sleep mode. You can see that the PIC is now drawing just 20 nanoamps. By pressing this button, we add in the real-time clock current. Now you can see that the PIC is consuming 800 nanoamps. Next, for watchdog timer, we'll switch out the plug-in module with one that has been programmed for sleep plus watchdog timer. Again, we press the sleep button, and now we can see that sleep with the watchdog timer enabled is now drawing about 500 nanoamps. Let's look at the current consumption scorecard. For sleep, the current was just 20 nanoamps. For sleep with the real-time clock, the current was 800 nanoamps, and for sleep with the watchdog timer, the current was 500 nanoamps. Next, we'll demonstrate the new XLP enhanced mid-range PIC16LF1937 device. Once again, we'll start with sleep mode and then transition to sleep with watchdog timer and then sleep with real-time clock. Pressing this button, we exit run mode and enter sleep mode. In sleep mode, you can see that the PIC consumes just 60 nanoamps. By pressing this button, we can now add a watchdog timer. The current consumed is only 500 nanoamps. Finally, by pressing the last button, we add in the real-time clock. Current consumed in this mode is now 500 nanoamps. So again, let's look at the current consumption scorecard. For sleep, the current was 60 nanoamps. For sleep with watchdog timer, the current was 500 nanoamps. And for sleep with real-time clock, the current was also 500 nanoamps. Now let's look at a leading competitor, the MSP430. The part being tested is the 2252, which is similar in memory, pins, and features to the PIC16LF72X family and the PIC16LF193X family. As we enter sleep mode, or LPM4, you can see that the MSP consumes about 100 nanoamps in sleep. This is 5 times higher than the PIC16LF72X family and nearly twice the value of the PIC16LF193X family. We can enable the watchdog timer by pressing this button. In LPM3 with watchdog timer, the current consumed is about 300 nanoamps. If we switch to LPM3 with the real-time clock, You can see that the current consumed is about 1.4 microamps. This is nearly twice as high as the PIC16 LF72X family and 3 times higher than the PIC16 LF193X family. And again, let's sum it up with the low current scorecard. For sleep, LPM4, the MSP430 consumed 100 nanoamps. This is 5 times higher than the PIC. For sleep with watchdog timer, LPM3 with the VLO enabled, the part consumed about 300 nanoamps. And for sleep with the 32 kilohertz timer running and a real-time clock, the part consumed 1.4 microamps. This is 3 times higher than the PIC. As you can see from the test results, there's only one microcontroller architecture that delivers the world's lowest sleep current, and that's the PIC microcontroller featuring nanoWatt XLP technology. Thank you for joining me for this second demonstration. You can find more information about Microchip's extreme low power microcontrollers at www.microchip.com/XLP.